For the second part of section 4.1, we're now going to look at graphing lines, and specifically graphing lines when we are given an equation that is in what we call standard form. Standard form is this right here, when we have an x and y term both on the same side of the equal sign, and then some number by itself on the other side of the equal sign. That's what this ax plus by equals c means. So our example that we're asked to graph is actually in that form. 3x minus 4y equals 12. We have our x and y terms on the same side, and it equals some number that's by itself on the other side. Now this first way we learn to graph these kinds of equations in math is using the x and y intercepts. It's not a bad method. It's actually pretty nice when you have a line given in standard form. We're going to learn some other methods here in the other sections of chapter 4 that maybe are a little bit easier, but really when you're given an equation in this form, this is a pretty handy, a pretty helpful method to use. So we are going to be using the x and y intercepts to help us graph this line, because once we know the x-intercept and the y-intercept, we can plot those 2 points and then just draw a line through those points, and that line is going to represent this equation here. All we need is 2 points and we can draw a line. But since we're using the intercepts, we have to kind of remember what we talked about in that first video. So in case you skipped over that, let's review something real quick here. Starting with the x-intercept. Remember, the x-intercept is a point that lies on the x-axis. And for it to lie on the x-axis, it can't be up or down any from the origin. It has to lie at the same height, up or down, as the origin is. So that means any point you have that's an x-intercept, since it has to lie on the x-axis, its y-coordinate is going to be 0. So it might have, a positive or negative x-coordinate, like in this case 2, but the y-coordinate will always be 0. And with your y-intercept, since it's lying somewhere on the y-axis, it could be up or down something, up somewhere or down somewhere on this line. So it could have a positive or negative y-coordinate, but since it's not to the left or right any of the origin, it's always going to have 0 as its x-coordinate. So we'll use those two things to help us find our x and y coordinates down here for our equation. So like we just said, for the x-intercept, we know the y-coordinate's always going to be 0, so in this equation we can just set y equal to 0 and then solve for x and find out what does our x-coordinate have to be if our y-coordinate is 0. So let's do that. We have 3x minus 4y equals 12. So 3x, we don't know what that x is, that's what we're going to solve for, minus 4 times y, well, we're putting in 0 for that y, and that's what that means. That just means 4 times 0 equals 12. Nice thing about putting in 0 for a variable is anything times 0 gives you 0. So minus 4 times 0, that's just going to essentially cancel itself out. So then we have 3x equals 12. The y portion of the equation just completely drops out when we're finding the x-intercept. Last step, all we have to do then to find our x-coordinate, divide by the coefficient of 3 to get x by itself, and we get that x equals 4. Okay. So what we've just discovered here, last step, canceling out the 3's, is that when y was 0, x had to be 4. So that right there tells us an ordered pair. Our x-intercept is the ordered pair 4, 0. Because remember, in an ordered pair, your x-coordinate always comes first, your y-coordinate always comes second. So we can go to our graph and plot the x-intercept. Remember, this is our x-axis, this is our y-axis. The point 40 would be right there. Alright. So, again, let's label it 40, and that is our x-intercept. That point right there. Now let's do the same thing, but only kind of the opposite to find our y-intercept. our y-intercept is always going to have an x-coordinate of 0. So we put in 0 in for x into this equation, which is going to cancel out the x piece, and then solve for y to find what is the y-coordinate when x equals 0. So, rewriting our equation, 3 times 0 minus 4y equals 12. Plugging in that 0 for x, 3 times 0 is 0, that cancels out that part of it. And now we are left with minus 4y equals 12. We just have to solve this now for y. So divide the coefficient, negative 4, out of both sides. Negative 4 over the negative 4 cancels each other out, gives us y by itself. And 12 divided by negative 4 gives us a negative 3. So that right there tells us our other order pair of our y-intercept now. When x was 0, our y-coordinate would have to be negative 3. So 0, comma negative 3 are the coordinates of our y-intercept. So we can go to our graph now. Again, plot the point 0, negative 3. Well, we're not moving left or right any, but we're moving down to negative 3 on the y, on the y-axis. So labeling that point 0, negative 3, that is our y-intercept. And as I was saying before, with any line, as long as you have 2 points, you're good to go ahead and graph that line. Because there's only one line that could go through both of those. So I'm just going to set my ruler here, draw a line through these 2 points, and we've just graphed the equation. We've just graphed the line for the equation 3x minus 4y equals 12. So that's why when it's in standard form, finding the intercepts, graphing using the intercepts, pretty nice method because you can just plug in the zeros to find the other coordinate. Alright. So then the last part of 4.1 is special cases of the standard form. What about when you have a horizontal or vertical line? Because those equations are actually going to still be in standard form, but they're going to look a little bit different. So the way to remember what kind of equation results in a horizontal line, horizontal being like our x-axis, what kind of equation results in a vertical line, vertical being like our y-axis, the up and down. Here's an easy way to remember it. Equations that only have an x equaling some number in them only cross the x-axis. Equations that only have a y equaling some number in them only will cross the y-axis. So for example, let's say we have the equation x equals, doesn't really matter, how about x equals negative 6? Okay. Well, it only has x in the equation equaling some number, so it's only going to cross the x-axis. So what it's saying is if you go to negative 6 on the x-axis, draw a horizontal line, or sorry, a vertical line through there, then that is going to be the line of the equation x equals negative 6. If we were to draw a horizontal line through it, it's going to end up crossing through the y-axis as well as the x-axis. So let me write this in again. Remember, that's our x-axis, that's our y-axis. Okay, so we go on the x-axis, draw the point x equals 6. Since it only has an x in the equation, it's only going to touch that x-axis. It's only going to cross that x-axis. So the equation x equals negative 6 would be this line right here, a vertical line. Okay. So x equals negative 6. Just like any equation that's of the form x equals some number, is going to be vertical. Now kind of the opposite then is if you have an equation with only a y in it. That's only going to cross the y-axis. So for example, how about y equals y equals 5. So go to your y-axis, draw a point at 5 right there. Well, for a line to only cross that y-axis, it would have to be a horizontal line. Okay, straight left and right. So the line y equals 5 is going to look like this. It'd be a straight horizontal line. So there are your two kind of special cases of the standard form. If it just has an x equals a number, it's going to be a vertical line. If it just has a y equals a number, it's going to be a horizontal line, because the y equals only crosses the y, the x equals only crosses your x-axis. And that's it for 4.1.